Hello, I am Mohammad Rashid Ansari from Alma Better Cohort Oracle. In this video, I am going to discuss 5 questions out of 25 questions of Capstone Project 2, which is given by Alma Better. So, those 5 questions are: Question 1 is power of 2. Question is, a couple of issues are present in the provided code. Identify and rectify these errors to ensure the code function properly. So basically in this code we have to find the error. In from line number 7, function is power of 2. Here n is integer, and in line number 9, return n is greater than 0, that means positive, or here is the bitwise AND operation is performing here. So if the value is greater than 0, then also this code will return true if true for the number is power of 2, but the all number which is greater than 0 is not the power of 2. So for that we have to use AND operator instead of OR operator, and in this case the bitwise AND operation, it performs like, for example, if we take example 2 is the power of 2 or not. So any number which is power of 2, it will have only one bit of 1. That means how we can write 2 in the binary representation, like 1 0, and n minus 1 will become 1, so 1 will represent like 1 0 1. So the overall will be 1 0 0 0 1 0. So that means here it will giving 0, so it will satisfy. So it's the power of 2, so it will return true. So here is the correct solution. This is the correct solution. I have written here this solution. So if we talk about time complexity will be constant, because the bitwise AND operation takes O1 time, because it's a simple bitwise operation and does not depend on the size of the input. So that's why time complexity is constant. If we talk about space complexity, as the space used by the function is constant and not related to the input size, so the space complexity is constant. Let's move to the next question. Question number 7 is palindrome. So in this question is, provided alternative code implementation different from one you have been given. Write the code using two pointer approach. So basically in this question we have to write the same code using two pointer approach. So we move on to solution 2. Let's discuss the solution 2. So line number 26, function is palindrome. We have to check the given number is palindrome or not, satisfying the palindrome or not. Okay, so function is palindrome. Here n is the number. Line number 27, const num str equals to n dot to string. So here number will converted into string. In line number 28 we declare a variable left is equals to 0, and in line number 29 right is equal to num str dot length minus 1. Basically this left and right are the pointer. Left 0, that means it will be first, it will indicating the first index of the string, and the right indicating the last index of the string. Now comes to the line number 31, while loop. So here in the while loop there is a condition left is less than right. So to satisfy this condition we have to have two minimum 2-digit number to satisfy this condition left is less than right. Now the condition is if num str left is not equals to num str right. Num str left, that means the first index, the first value of the string, and the num str right, that means last index of the value of last index. If the both the value is same, then the pointer left will increment, that means left index 0 will go to index 1 and the right index will decrement. The right is now last index, it will go to the second last index. It will keep on checking if the condition, if any value is not equals, if it satisfies not equals to, then it will return false, that means it not a palindrome. And it, after checking every first and the last, keep on checking, it will satisfy that every value is same, then in that case it will return true. So if we talk about time complexity is log n due to the conversion to a string. And if we talk about space complexity is log n due to storing num str is O log n. So let's move to the next question. Question number 11. The question is, you have been tasked to develop logic for the provided coding problems. Write a JavaScript function to find a peak element in an array of integers. A peak element is defined as an element that is greater than or equal to its neighbors. Basically in this question we have to write a code for finding a peak element in an array, in an input array. Okay, so here in the line number 8, the nums is array, this input array. Now we are considering a variable, let left is equals to 0 and the right is equals to nums dot length minus 1. That means left indicates the first index of the array and the right indicates the last index of the array. Basically this code is follow the binary search algorithm. So let's come to the line number 12, while loop. So in this condition left is less than right, it will satisfy when the array contains more than one element. Okay, then comes to the line number 13. We declare a const variable mid is equals to math.floor left plus right divided by 2. That means why we use math.floor, because if the number of element in an array is even and in that case this right will become nums dot length. If the number of element is even, this nums dot length is even, minus 1 will become odd. So here when we add left plus right divided by 2, it will give you the fraction. So to get an integer we use math.floor. So we get the mid, means the mid index of the array. Now this condition, if nums mid is greater than nums mid plus 1, nums mid is greater than, so if nums mid is greater than nums mid plus 1, right will comes to mid, right equals to mid. If we take example here in this array, nums mid is greater than mid plus 1. First of all, if we calculate mid here, the mid will become this 3. And if mid is greater than nums mid, means 3 is greater than 5. No, 5 is greater than 3. So in that case nums mid is less than nums mid plus 1. So it will the left pointer will comes to mid plus 1. So the left pointer from 1 it will comes to the mid plus 1, means at the 5 position, means here this 5, and then again that whole process will begin. Again it will find mid, then again it will check nums mid is greater than nums mid plus 1, again it will gives you, and ultimately it will gives the left mid plus 1, means this 6 as a peak element. So like this code works. If we talk about time complexity, the code uses a binary search approach to find a peak element, so that the time complexity is O log n, where n is the length of the input. And if we talk about space complexity of the function is constant, that means it has a constant space. So let's move to the next question. Question number 16. In this question, what we have to do, we have to just compare the traditional approach and the optimized approach. So let's begin. So in the traditional approach, a headset is used to store all the elements from the input array. This headset, it iterates, in this case this for loop, it iterates through the integers from 1 to n, checking if each integer exists in headset or not. If an integer is not found here, if this integer is not found in the headset, it is considered as the missing integer. Okay, and if there is no missing integer, then in case it will return 0. So this is the traditional approach. And if we talk about the time complexity, building the headset takes O(n) time. Iterating through the integers from 1 to n, it takes O(n) time, linear time in the worst case. So overall the time complexity, if we talk, it's the linear time complexity. And the space complexity, the headset stores all elements from the array. So that's why the space complexity is also linear. Let's talk about optimized approach. The optimized approach doesn't use extra space like a headset. Like if we see here headset, but in case of optimized approach, there is no extra space like a headset. Instead, it performs in place swapping of elements in the input array to arrange them in their correct position. In this, just swapping the correct to them there where the correct position. It iterates through the input array and swaps element to put each element in its correct position if possible. Then in this for loop, it iterates through the modified array to find the first element that is not in the correct position, which is the missing integer. So if we talk about time complexity of the optimized approach, there is a swapping is performed. So swapping is performed in O(n) time, and the second iteration to find the missing integer also takes O(n) time. So the overall time complexity is linear O(n), and space complexity of the optimized approach is constant. Why constant? Because optimized approach uses constant space as it operates on the input array in place. So at last, the optimized approach is more efficient in terms of space complexity, as it doesn't require additional memory to store elements in a headset. And they have both traditional and optimized approach have same time complexity, linear. So here I have written all the comparison between traditional approach and the optimized approach. So let's move to the next question. Question number 23. So the question is, write code to demonstrate question worst and best case scenarios. Write a JavaScript functions to flip and invert a given binary image represented as a 2D array The goal is to horizontally each row of the image and then invert each element. 0 becomes 1 and 1 becomes 0 in place. Okay, so basically in this question what we have to do, we get an array, and in that there is sub arrays. Every sub array contains two numbers like 0 1, and we have to convert 0 to 1 and 1 to 0. That means we have to flip. Okay, so first we discuss about worst case. In this, from line number 7, function was flip and invert image here is what? Array. Const num rows is equals to image dot length, the length of the array. If num rows is equals to 0, return empty array. That means if there is no, if the length of the array is 0, so in that case it will return empty array. Now const num calls image 0 dot length. That means it is a variable, declaring a variable num calls and image 0 dot length. That means it's a length of sub array, at the first index of the array. Const flipped image new array nums rows. Okay, for here is the loop. In this we are going to flip. We check if the number is every array, every sub array is going to be checked. Again, this is the outer loop. This loop iterates the every index of the main array, and this loop iterates the every index of the sub arrays. And if there is a number, if there is image I j, if there is a number is 0, it will replace with 1, and if there is 1, then it will replace with 0. So like this it will return the flipped image. In the place of 0 it will return 1, in the place of 1 it will return 0. So if we talk about time complexity, the time complexity is O num rows into num columns, both space and time complexity. If we talk about best case, in the case of best case, it is using for off loop. Instead of normal for loop, it will using for off loop. And here is the two pointer, means from the left and from the right, from the starting index and from the last index of the array. For satisfying this condition, left is less than, here is the while loop, left is less than equals to right. If row left is equals to row right, then the row left will become 1 minus row left. That means if row left is 1, it will become 0, 1 minus 1 0, and if 0 it will become 1. So like this it will increment left and it will decrement right, and after doing this it will return the image, the flipped image. And in this case also time complexity is O num rows into num calls, and the space complexity is linear, sorry, space complexity is constant. So this is all about the code.